Alright, and welcome back. Okay, so yesterday I made a huge recap of GraphQL module from Node here. Well, talking about what is GraphQL, which is a new query language. Uh, and the beauty of this is that we can see how our data, all of the different pieces of data in the server relate each other. And it all starts by describing the data using schemas. And if you want to fetch data, you want to ask for data, you use GraphQL query. And since the GraphQL query is much like selecting property of an object, and the beauty of this is since the query itself match really closely the resulting objects that we get, we can predict what our query will return, including is the property fields, regardless how the data is stored. So this is one of the great selling points, especially for two kind of problems that Facebook in 2012 they lay out on their specification videos. GraphQL spec, the overfetching and underfetching. So what happens is that on RESTful architecture, anytime you want to make or anytime you want for some collection of data, you make an individual request and you get an individual response. And if you want to query multiple data or collection of data to combine data on the front end, you have to do that each separate request. So that is also known as the underfetching, because we lose time anytime we make additional unnecessary requests, query multiple collections, thus increasing the page load time. And since the server sends an additional unnecessary data, we need to filter out on the client to show the relevant information. And that is known as overfetching. So GraphQL solves that by having one single entry point where you can ask for the data and you hopefully can get the data that you need. Only that. So Facebook created that in 2012. I also looked at how can we create our first GraphQL query using the GraphQL tool. This browser built-in tool for testing GraphQL queries. I also saw the Relay, which is a framework that allows you to interact with the GraphQL service using the React framework, and more high-end products such as Apollo. That before deep dive into that area, I look at a little bit of example of first how to create GraphQL query and to understand deeply how it works, the mechanism of the GraphQL and how do you set up a GraphQL service. We began to build that from scratch. So I started using the GraphQL package and the Express middleware for that. So I define is a small type system. Again, the idea here is to make yourself familiar with the concepts and the mechanism. So the type system is a string where it allows you to define is the capability of this GraphQL server that is used to check if a request operation is valid, if a request GraphQL operation is valid, to determine the type of the result response. And again, all of this comes from the specification here. Working, yeah, we can look at the latest here. I mean, the latest here uh, on type system. Okay, uh, and describes the input type of variables to determine if a value provided at request time is valid or are valid. So back to the example here, specifically with this with our GraphQL, a simple example of a GraphQL server. Okay, we define a type query, which is the entry point for all GraphQL server, using is the build schema for that, and to test using Postman's and Insomnia to see how that worked underneath the hood, because after all, it relies on the HTTP endpoint or the HTTP server. However, which is one of the trade-off or the disadvantage, since this is not a RESTful architecture, meaning that to query data, you make a HTTP post request here, a HTTP post request. Another disadvantage is it's not that easy to catch. Even though that GraphQL provides you some couple examples of how to do that, in contrast with RESTful, where we have already proven mechanism to do that. And the other is that this flexibility, the other disadvantage is that this flexibility adds complexity. Again, it's up to you to analyze when you can use GraphQL and for which endpoint or which collection of value. Uh, it is usually to see RESTful and GraphQL for authentication service in combination to work with that. And one of the advantages of using GraphQL is since it provides schema and types, and it speeds up the development since now there is no more underfetching and overfetching. And as I move on here in this course, then I create I design an e-commerce schema, a pretty basic schema, but the whole idea is to again get yourself familiar with the concept and the mechanism, and understand that deep nested objects are very common, not only in e-commerce application, but also in any application with some technical depth. So makes GraphQL a great candidate for that, since it is actually very easy to query really complex data structures and get the data that you want. Our API now is organized in types and fields rather than endpoints. So making unnecessary or yeah, making or making querying multiple collection of data unnecessary, like in a RESTful API. Okay, so yes, so I start to look at what are the way of how can we define is our type system, and asking a couple questions. How can we break down our type system into multiple files? How can we organize our project structure by feature, which is something very common in Node server, in how can we organize our server so when we need to add more complex logic to fetch our data, it makes our life much more easy and make more maintainable our application. So all of these questions are rely on scalability. So they can be or they are under the umbrella term called scalability. So I saw an npm package called GraphQL tools that allow you to do that. And meaning is you can rely on, for example, to create your type system using next executable function here, okay, here, next executable function, and define is the type definition or the type system as an array. Okay, so by breaking your type system into multiple files, which is like a pattern that is here, defining is the type or the schema of that particular collection or document, and end with .graphql. So we did that for products and orders. Okay, so you can have as much as you want, no problem. And how can we load all of these files and import that here in our type definition? Luckily for us, we have a function from the GraphQL tools called load file sync that what it does is to look up for the files with GraphQL extensions, okay, that ends with GraphQL. Cool, because now that our life is way much more simpler by modularizing our application here, okay, I'm going to explain a little bit more about what is going on here, especially for the query here. I define is some type here for the product and the review, and also defining is the type of or the primitive, and also defining is a collection as well. Like here, you can define is nested collection here. And defining is a query where it's going to merge with other GraphQL documents. And this approach of breaking multiple types into files is a great approach as long as you define a proper schema, right? And there is no name conflict. Okay, great. And since any GraphQL server has two main components, the schema and the resolvers. So what are resolvers? So to answer the question, is how we query data. So GraphQL query always check if a request is valid by looking at the type system and then executing the query. So when executing the query, the value of a property is determined by a function called resolver. In other words, a resolver is a function to identify is the value of that property. Simply put, the TLDR. Okay. So where we are here, okay, with the resolver. All right. So what happens is that when you define is the property in your query, right, the server will call the proper resolver for that, and the server once it has called all the resolvers found it in that query, wrap up and send it back to the client. So I started to saw, or I saw how can we create this, or how can we make use of the resolvers specifically here, since we're using as a root value to determine what the data comes from our API for demo purpose. And even though that here right now we are mocking our data, uh, so we are using is the in-memory uh, to define is the this hard-coded data. It's not realistic, okay? Since it's not realistic, we're going to call the resolvers to see what are the main benefit of using that. Okay, so the way of using the resolver is that, or the way it works is that GraphQL call the required resolvers once you make a query, and then we fetch all of the data that we need inside of the resolver function, and the data gets sent back to our client. Okay, so it's pretty much like this. Okay, uh, we define here as our files that ends with .resolvers.js, and here is where we going to call is we can call synchronous function or asynchronous function, and that's one of the great thing of resolver. That's the beauty of resolvers, and it allows to do that. So we may have is we may have, or we may call different APIs where we store the state of our application and then send it back to the client. So resolver is kind of the magic, but so it's one of these magic functions uh, underneath the hood that allow us the or that solve the underfetching and overfetching problems. So okay, so I test this using it in a way in a promise day or an async operation. Okay, this is also part of the good practice, especially when dealing with promise in Node. This best practice comes from this best practices here, uh, like this. So Node best practice. Again, this best practice is up to you, and it's highly contextual as well. So when we're dealing here with errors like this, use await and then 16 terms for promise of error handling. So and again, is this the other code style practice and testing an overall quality practice as well. This is a combination with Joen, this long-term Node.js sponsor, with the uh, the Node.js community. You know, with the Node.js community here. So back to the code and see that it can become quickly, because the issue it was that since we can define as a resolver here on next executable function at the server.js here, okay, at the server.js, it can quickly becomes lengthy and verbose and unmanageable. So we split the resolvers per functionality use in files that end with .resolvers, okay, We export that as a model with query and defining all the query that we want for that. All right. So, okay, this is making the resolvers much more scalable. And by looking at the anatomy of the resolvers real time here, so looking at the anatomy of the resolvers, so we have the first argument as are the parents. This is the argument that use the root value and we pass in. The other are the args that is used when we have parameterized queries. For example, we wants to filter out data and send it back to the client. Then we have context that is used to share data across resolvers. So for example, if you want to share user authentication data across different resolvers, and the info, which indicate is the current state of the operation. So another good practice is that if you're not going to use that argument, use the lowercase or use an underscore for that. Okay, great. So because we want to keep things simple and modular as possible, most applications rely on creating is a data layer, and this okay. So this data layer that contains all of these data access functions that are exported here. In our case, we are hard coded this data so far for demo purpose. Okay, and the course here, uh, the core here show us how can we uh, create parameterized resolvers. Okay, how can we pass is, or how can we create parameterized queries? In our case here, okay, this is parameterized query product by price. So here's where you define is the type of data, the argument, and the type of data, followed by a required. And again, this is just to help us simplify our lives, so we don't have to check on the backend for that data, or to check if that is undefined or not. So we're reliant that the front end is sending that data in. A common way to define queries here is the following. So you go to the type definition schema, product.graphql, define the query or your parameterized query, then go to the resolvers, the proper resolver, define that parameterized query, okay, and then call that function from the data access layer and pass that data. So by calling use the function from the data access layer, okay, you're going to perform is the asynchronous API database operation. In our case, remember we're fetching is the data in memory, so that's what we're using is this, right? Again, this is for demo purpose. Okay, makes sense, yeah, makes sense. Then the course also challenged us to create or to fetch products by ID. Pretty straightforward. Again, this the same. I define is a parameterized query, parameterized query in the schema. Then I already defined is the resolvers. Again, you are defining here the resolver because I already scaled this, right? This is when you are ready make a GraphQL scalable with this, because otherwise you will have to import that here or define that in the server.js, but you don't want. Again, this is something that becomes large, unscalable, hard to maintain, and okay. So I define is the query here. Since I'm not going to rely on the parent, so I leave that using the underscore. I'm going to get is the argument from that and pass those arguments to the data layer function, where this is going to perform is that async operation. Okay, in our case, it's just find that product by ID, right? Cool, cool. All right. So what's next? So what's next? What's next? What's next? Exercise. Query product by ID. We already do that. Okay. So yeah, what's next? What's next? What's next? Tell me, what's next? What's next? Oh, you gotta be. Okay. Login here. I'm using something called KeyPass as my password manager. Okay. Continue. Yes, sign. Okay. And that's right. So the using is then look for GraphQL. That's right. And we are here looking at mutations. Looking at mutation, implementing mutation on the server, and exercise and add new product, GraphQL with Apollo. And that's right. That's all? Really? Pretty straightforward? Okay, interesting. Okay. Okay. And then I look with socket. Then I go with socket. I'm quite familiar with socket. In fact, I also helped to build a startup, a chat. I also helped to build a startup, a chat using socket.io for that. And then perhaps using is Dino. But again, Dino is for long term. Dino is for a long term, Dino is for a long term. Dino is for a long term. Dino is for a long term. Yeah, complete. Dino is for a long term. Yep, Dino is for a long term. Okay.
Server. We also welcome back. Believe it or not, GraphQL isn't only for getting data from the server. We also need to update the existing data in our GraphQL servers. We need to create new data and delete data that's not useful to us anymore. What's the GraphQL way of doing all these things? Let's find out in this video. So far, we've been using GraphQL queries, which fetch data from the server. That's the most basic type of operation that GraphQL servers support. With APIs, getting existing data and reading it is probably the most common thing you'll do. That's why GraphQL focuses on doing queries really, really well. But any real-life backend application needs to support all of our CRUD operations, including creating, updating, and deleting. To do any of these things that change data on the backend, we use what's called mutations. These mutations, along with queries, which we've already seen, are the two main types of operations that GraphQL servers support. So let's get on with it then. How do we make mutations? Right now, none of our products have any reviews associated with them. That's why the value of our reviews field is null. Let's find out how we would let our users add reviews to any product. As you know, when we're getting data from our GraphQL server, we use what's called a query. We've seen that the word query is implied when we don't include the type of the operation. Now, if we're making changes on the server, we make this explicit by always typing the mutation keyword followed by some object. So I'll clear this left-hand panel here, just leaving the mutation part. But we're going to see that mutations are very, very similar to queries. Instead of the names of queries, like orders or products by price, we include the name of the mutation that we're making. To add a new product review, we'll name our mutation add new product review, keeping things simple. Now, just like with queries, we can pass in arguments into our mutation. But unlike queries, the arguments in our mutation contain all the data that we're saving on the server. For reviews, the data we need to capture is a required rating, that's an integer, as well as an optional comment. But also, we need to associate a review with some product, most likely using the product's ID. Those fields correspond to the arguments we pass to our add new product review mutation. Maybe we're adding a review for our red shoe, which had an ID of red shoe. So we would pass that ID as an argument, just like with our queries. ID for the product that we're reviewing is red shoe. What about the contents of our review? We pass that in next. We'll rate these red shoes a 5 out of 5, and our comment will be that they're really great for coding. All right. Now, our mutations, just like our queries, can return some data corresponding to the mutation that we made. For example, maybe the server is generating a unique ID for our review that we don't already have access to on the front end. We could get that just like we do with queries, adding these curly braces and putting in the names of the fields we're interested in from the response. What we're essentially doing here is making a change on the server and getting the newly updated data back all in one mutation. This is especially useful if we're updating part of an object that already exists and we want to get the final state of that object after our changes. We'll keep things simple and just return back the rating and comment for the review that was just created. To be absolutely sure that everything is working, we can get back the rating we just put in. And there we have it. Our first mutation, nearly identical to a query, with the exception that we use this mutation keyword, and our mutation is changing some data in our server. Let's keep things short and implement this mutation in the next video. We'll see that mutations are very similar to queries under the hood. The key thing is that we use the mutation keyword to let us know that we're about to make some changes and not just fetch some data. The word mutation comes from mutate, which just means to change. All right, let's make some changes to our GraphQL backend. I'll see you in the next one.
I just want to transcribe this first thing. Okay? Just want to transcribe is this, because to me this narrative of this storytelling is something important, especially if you want to make sense of the thing that you're learning. You know, is to make sense of the thing that you're learning. That's what that's exactly what I want to do here by transcribing this. So mutations in action. Mutations in action. We're going to do this exactly. All right. Mutations in actions.
Welcome back. Believe it or not, GraphQL isn't only for getting data from the server.
Believe it or not, even though those sentences that for other people might be silly, but it can help you as a starting point to sell you something or to tell something. Believe it or not, lo creas o no, you know, uh, believe it or not.
We also need to update. Believe it or not, GraphQL isn't only for getting data from the server.
So believe it or not, GraphQL is not only for fetching data from the server.
We also need to update the existing data in our GraphQL servers.
So we also need to update existing data in our GraphQL. Your GraphQL.
We need to create new data. And
Exactly. We need to create new data and
delete data that's not useful to us anymore.
exactly and delete data that is not useful. Delete data. Nothing here is deleted.
What's the GraphQL way of doing all these things?
Okay. What's the graph? What's the GraphQL? Yeah, what's the GraphQL? Uh, what's the GraphQL way of doing all of these things?
Let's find out in this video.
Let's find out in this video.
So far, we've been using GraphQL queries, which fetch data from the server.
Mhm. So far we have used query
That's the most basic type
that's query to fetch data from our server.
of operation that GraphQL servers support.
Mhm. That's the most basic type. That's the most basic operation that GraphQL support.
With APIs, getting existing data and reading it is probably the most common thing you'll do. That's support. With APIs, getting existing data and reading it
Exactly. Yeah, support. With okay, with API gathering data and deleting
is operation that GraphQL servers support. With APIs, getting existing data and reading it
okay, gathering data
of operation that GraphQL servers support. With APIs, getting existing data
okay, with APIs getting existing data and reading it is the most
and
common
reading it is probably the most common thing you'll do.
Mhm. Is probably the most common thing you you will do.
That's why GraphQL focuses on doing queries really.
So that's why GraphQL focus
And reading it is probably the most common thing you'll do. That's why GraphQL focuses on doing queries
focuses on doing queries.
really well.
Exactly. So that's why GraphQL focuses on doing queries really really well.
But any real-life backend application needs to support all of our CRUD operations.
But but
Really well. But any real-life backend
but any real life backend application needs to support
application needs to support all of our CRUD operations.
needs to support all of our CRUD operations,
Including creating, updating,
exactly, including all of our CRUD operations.
and deleting. To do any of these things that change data on the backend, we use
Mm, create, update, and delete. So to do all of this thing in our backend,
what's called mutations.
we use something called mutation. Okay, we use something called mutation. What is this?
These mutations, along with queries, which we've already seen, are the two main types of operations that GraphQL servers support.
Okay. So this operation are the two main the two main
With queries, which we've already seen, are the two main types of operations
are the two main types of operation. Of course, for more advanced use case, you can rely on other operations.
that GraphQL servers support.
That GraphQL server supports.
So let's get on with it then. How do we make mutations? Right now, none of our products
Okay, so how do we make mutations? Okay. Okay.
Have any reviews associated with them. That's why the value of our reviews field.
So yeah, I'm going to leave this. Uh, yeah, I'm going to wrap up this video. Uh, until next time, so take care. Bye bye.